Hi, welcome to my channel. My name is Pat. I live in Penticton, British Columbia. I'm not a geologist, but I hike a lot and keep an eye on what I'm walking on. I've enjoyed watching the YouTube videos prepared by Nick Zentner of Central Washington University, so I'd like to share examples of the rocks we find here in southern BC. Penticton is 75 kilometers north of BC's border with Washington State at the south end of Lake Okanagan. The area has been extensively glaciated. As the glaciers waned, a lake filled this valley with a shoreline much higher than today's lake. Sediment from that lake remains along the valley walls as silt bluffs that are over 30 meters high. The silt provides us with agricultural land for vineyards and orchards, but it hides the bedrock. Fortunately, numerous rock cuts for road and railroad construction gives us a peek. The rocks we'll look at in this video are within 20 kilometers or so north of Penticton on both sides of Lake Okanagan. Courtesy of Google Earth, here's the area of interest. A surface geology map of the Okanagan Watershed compiled by Andrew Okulich of the Geological Survey of Canada is available online. Here's a part of that map overlying the Google Earth view. Much of western British Columbia was joined onto North America by plate tectonic collisions. The Okanagan area was added about 170 million years ago as part of the intermontane superterrane. Then, 50 million years ago, collisional compression changed to extension and the Okanagan area began to pull apart, creating the Okanagan Valley Fault. That fault is the main story here. Generally it follows the lake so we can't see it, but the stops on this video will illustrate some results of that extension. The first two stops are on the east shore, highlighting Okanagan Gneiss in the footwall of the Okanagan Valley Fault. Next, we'll cross the lake to Summerland. Here in a very small area we can see lava, sedimentary rocks as the lava was aggressively eroded, and the underlying intrusive rock of the Bromley batholith. Then, heading back south towards Penticton, there's a road cut exposing some limestone and volcanic and intrusive rocks on the east side of the lake as the Okanagan Valley's fault swings east briefly. The first stop is a road cut about 9 kilometers north on the road to the village of Naramata. This is the location of figure 54.4 in the Okanagan Geology South guidebook by Murray Roed and Robert Fulton. The rock is gneiss and is typical of the east side of the lake. Gneiss is a layered metamorphic rock formed when the rocks are heated with shearing strain at depth. The layering, called foliation, separates light-colored lower melting minerals, the quartz and feldspars, from bands of darker iron and magnesium silicates. Weathered surfaces are often rust-colored. The rock from the road construction splits into rectangular pieces, and it's handy for stonework. There's a lot of it in Naramata. The next stop is along the Kettle Valley Rail Trail at Little Tunnel, about 16 kilometers from Penticton. The railroad was completed during World War I and connected the coast and the Boundary Mining District to the east. The village of Carmi in the Kettle Valley is about 40 kilometers east of Penticton, but from there the railroad swings north almost to Kelowna in a 140-kilometer end run around the Okanagan Highland. It gradually descends to Penticton, where it could cross the valley. The railway is no longer in use, and the road bed north from Penticton is maintained for non-motorized recreation. It's a great cycle trip with fantastic views and many rock cuts. I think the second video clip at the north end of the tunnel also records the song of a canyon wren. Here there's some lovely unweathered gneiss. Here's another look at the geology map. Notice the red squiggles. These indicate that the rock is myelinite. On the map legend, it's labeled as orthogneiss, i.e. derived from a granitic protolith, with possibly Proterozoic age. This rock cut faces west. While you enjoy these gorgeous rock photos, I'll paraphrase a couple of lines from a 2012 Geological Society of America paper by Sarah Brown and others, partially titled New Constraints on Eocene Extension Within the Canadian Cordillera. The data presented in this and previous studies suggests that the Okanagan gneiss was exhumed from at least 20 kilometers depth to shallow levels in the crust less than 3 kilometers during the Eocene, circa 56 to 45 million years. We estimate a horizontal displacement of 64 to 89 kilometers to the west, with a mean dip angle of the Okanagan Valley shear zone at 15 degrees. Exhumation and cooling were, therefore, contemporaneous with volcanism in the hanging wall and sedimentation in the adjacent basin. There's no evidence for a pre-Eocene fabric, nor evidence for a Paleo-Proterozoic protolith. Therefore, we conclude that the Okanagan gneiss is not a piece of North American basement. So that last statement is interesting, since traditional thinking was that this area was the western edge of ancestral North America, the craton in this area. A book and a film entitled Where Terranes Collide by Chris Yorath of the GSC is viewable on YouTube and provides some good background. Next, we'll head to Summerland to see rocks that moved west on the Okanagan Valley Fault. But first, let's look east across the Okanagan Highland. The lake is at 340 meters elevation. Little Tunnel doubles that to 680 meters. The highland is topographically bland. It rises to 1,500 meters with a few high points near treeline at 2,100 meters. The Kettle Valley is less than 40 kilometers east. The peaks forming the skyline in this view are actually 70 kilometers away along the Granby River. Rocks along the axis of the highland are unmetamorphized, unfoliated granites. The slope of the eastern wall of the valley is roughly 10 degrees. Since the Okanagan Valley fault angle was steeper, the current erosional surface gets further below the fault as one goes east. From Little Tunnel, turning to the southwest, the high ground beyond Summerland is the Thompson Plateau. The high points there are also around 2,100 meters in elevation. In the foreground, the light-colored bedrock beneath the golf course in the walls of Trout Creek, and at the left edge of the view is intrusive rock, granodiorite, of Jurassic age. To the left of the golf course is Mount Conkle, a small provincial park with great mountain bike trails. It's lava, part of the Marin Formation. In the middle, the flatter areas are White Lake Formation, sediments eroded off volcanoes. At the right is Giant's Head, lava of the Marama Formation. The age range of these rocks is reported as 53.1 to 45.2 million years. Each of these formation names are locations southwest of Penticton where these rocks are more extensive. But here in Summerland, you can see a lot within a short distance. Giant's Head is a topographic highlight of Summerland. The Marama lava is dacite, compositionally the extrusive equivalent of granodiorite. We're going to visit its base on the southwest side. There's a small area there with columnar jointing. The width of the columns is typically less than 20 centimeters. Marama lava is dated at 48.4 to 45.2 million years. It's encountered in a number of places in the Okanagan, including Mount Boucherie in West Kelowna and Peach Cliff in Okanagan Falls. From Giant's Head, let's travel north on Highway 97 and pass through Summerland. After passing Sumac Ridge Winery, the highway turns towards the lake. Here we re-encounter Marama lava in rock cuts on both sides of the road. Secondary roads paralleling the highway make it a safe place to stop for a look. The lava is generally aphanitic without crystal texture, but may contain broken fragments. It's quite common to have calcite veining in the lavas we encounter here. Now turn and look south. The hill in the middle distance is sandstone, the start of a long section of White Lake Formation sediments. This view to the north along Highway 97 shows the lava rock cuts we were just at. If we turn here, we have sandstone. This is material eroded from the volcanoes and deposited in rivers and lakes in the Elongate Basin, which formed as the upper plate of the Okanagan Fault slid to the west. White Lake is southwest of Penticton, but these sediments are common throughout the Okanagan. Tony Hamblin of the GSC in 2011 published a detailed outcrop analysis at 3 locations, here at Sumac Ridge, at Glen Rosa Road in West Kelowna, and at White Lake. A good place to look and be away from traffic is a little further south, at the entry to Sumac Ridge Winery. This view is across to the west side of the highway. The rocks dip south and here represent 178 meters of thickness. The formation is wildly variable with sandstone, conglomerate, shale, coal, plant fossils, wood fragments, lava, volcanic ash, and pyroclastic flows. Here's some closer views from the ditch on the west side of the highway. On the east side of the highway, along the entrance to Sumac Ridge, there's good examples of the conglomerate facies. These views are looking east. Sumac Ridge is 170 meters above the lake. The geology map indicates that White Lake rocks continue down to the shore. I included a bit of video driving along Lakeshore Drive here to give a sense of how imposing the silt bluffs in this valley are and why it's hard to find outcrops along the lake. Just before reaching Crescent Beach, there is a small outcrop of White Lake Formation with large angular clasts in a light-colored matrix. Our next stop is to move to Hermiston Drive, a residential street on the western edge of Summerland. Here at this retaining wall, we'll look first at the rocks on its west edge. These appear to be granitic. Moving to the east end of the retaining wall, the rock is sandstone. Here the White Lake beds are dipping to the east. To the south and just west of Giant's Head, there's a small hill which is mapped as White Lake Formation. It's in the foreground in this view from Mount Conkle. The clasts in the conglomerate here are a mixture of volcanic and granitic cobbles. The Marin Formation lavas are quite variable in color and texture, and frequently contain feldspar phenocrysts. The presence of granite cobbles suggests that the volcanic cover was less extensive when this was deposited. Dropping to the south side of that hill, there's a parking area on Fenwick Road where you can access the Trans-Canada Trail. It's on the lower right in this view from Mount Conkle. At the parking area, on the east side of the road, there's a rock cut of that now familiar White Lake conglomerate. Turning to the southwest, across the meadow, at the entrance to Conkle Park, the bedrock is lava. It's mapped as a limpet lake member of the Marin Formation. It's trachyite and trachyandesite. Our next stop is the west flank of Mount Conkle, above the canyon of Trout Creek. At one location, about 760 meters in elevation, the talus and soil is red, weathered from volcanic rock of the Marin Formation, which forms the cliff above. Moving horizontally 150 meters across the slope, we encounter coarse, sandy soil, weathered from granite. Somewhere between this granitic outcrop and the lava cliff above is a contact between the Eocene lava and the Jurassic granodiorite. Here the lava is almost 200 meters higher than it is when we encountered it on the east side. The dark line mapped south of Giant's Head marks the position of a normal fault. The dots drawn on the north side of the line indicate that it is the side which has dropped. This view is to the northwest towards Giant's Head at the junction of Gartell Road and Happy Valley Road. At my feet is granitic rock, granodiorite of the Bromley batholith. The lava of Giant's Head on the opposite side of the fault was dropped, so the current erosion surface is older to the south and younger rocks to the north. Along the Happy Valley Road, which turns left, there's some small rock cuts. This is typical of the bedrock from here to Penticton on this side of the lake. Intrusive rock is the norm between the Summerland Fault and Penticton, but at a pullout on the northbound highway 4 kilometers north of the Okanagan River Bridge, there's an anomaly. Looking across the road, there's a rock cut with light gray ribboned rock. The rock is limestone. At the edges of the rock cut is intrusive rock typical of this area. Moving in from the margin, one sees granitic and quartz veins intruding the limestone. In the Okanagan Geology South Guidebook, this rock cut is figure 56.4. Murray Roed describes it as a xenolith, a piece of the country rock which was not consumed when the magma intruded around it. This is perhaps a hint of the Quinella origin of this area. The Quinella terrain is considered to have been a volcanic arc. The limestone would have been a reef along the shallow margins of perhaps a volcanic island. The limestone reacts with 6-normal hydrochloric acid. Our last stop is back through Penticton and around to the southeast shore of Lake Okanagan. Across the lake, the hill with the Penticton sign, is Munson Mountain, its volcanic rock. We'll have a quick look there, then below it, at the lake shore. The Okanagan Valley fault appears to deviate east of the lake here, so Munson Mountain is part of the hanging wall above the fault. The lava is mapped as the Kittley Lake member of the Marin Formation, trachyandesite dated at 51.6 million years. There's a small exposure on the east side of Munson. This looks like it could be volcanic breccia. Munson is surrounded by glacial silt, but down at the lakeshore there's a few exposures of bedrock. The shoreline exposures are salt-encrusted, perhaps sulfate salts, leached from the volcanic rock above. The rock is similar to the rock south of Summerland. It is not foliated gneiss. In Penticton at the Sycamoose Paddle Wheel Museum, there's an ore cart and plaque, and a pointer to the lakeshore below Munson Mountain. Along the shoreline there was a mine, variously called the Okanagan Mine, Lakeshore Mine, and Torpedo Mine. Although not particularly profitable, ore was extracted in sheared rock with quartz veins, likely just above the Okanagan Fault. The mine shaft, now covered by landslides, perhaps reached 27 meters below lake level. Our tour ends with the view north up the lake. Thanks for coming. The Naramata Bench is on the right. Munson Mountain is in the foreground. Giant's Head is across the lake directly behind Munson. Left of Munson across the lake, at the foot of Mount Naquala, is our limestone outcrop.